Hi, today we're going to talk about query optimization in hybrid databases, row, columnar, bitmap, and everything between. I'm Boye Song from Data Models Team Data Platform.
And I'm Ismail, also a member of the SQL team.
In Iris, we support two storage models, row-based and columnar. And this is great if you have two different data users. For example, you can have a data producer, which is an applications, and their primary focus will be using the data row by row. You might also have the data consumer on the same table for analytics, and their primary usage will be using data column by column. Iris offers great flexibility in table and index definitions so that users take advantage of all of these different type of indices. For example, for a table, you can use the default row storage and define columnar indices on some of the fields that you know that's going to be commonly used in your analytic queries. And in addition to that, you can define all the other indices that we supported for our table, including bitmap indices. This poses a unique challenge for our query optimizer, how to pick the best plan among these indices.
Okay, thank you, Boya. So before I jump to the an example, I want to explain briefly the hierarchy of our query optimizer or query engine. So almost every query goes through these 5 phases. First, we have the parser, then query analysis, and then the optimizer, the plan constructor, and code generator. When we first released Columnar 2 years ago and it became generally available, we were bypassing the optimizer. It means most of the brain power of our SQL engine was bypassed. But in 2025.2, we integrated the important optimizer phase into the columnar workflow. So now we can see all indices that we have defined on the table, and we can decide what indices are best to use that query. So I'm going to show you briefly what the optimizer solutions look like. So first we file an algorithm array that has the traditional row-based solutions, and also maybe bitmap, and then row-based, and then columnar solutions. And then we cast all these solutions or algorithms against each other. And then based on a cost-based model, we decide which plan is the cheapest. So this is an example of a query. Say you have a patient visit and you want to filter by whether the patient was admitted or not and the H1C results. So this is an example of a query that can benefit from both bitmap and columnar indices. Before this release, we can only use either columnar or row-based plans. So this is the plan that you'd get from a 2023 or 2024 release, where we read columnar data and then we do vector operations to for example, to test this condition on H1C. But starting in 2025.2, we can combine these two technologies together. So we can choose a bitmap on a low cardinality condition, is admitted equal to true, and then we can use another columnar index on the other condition, and the optimizer can make these decisions internally without you having to tune your query. So this example, if you execute this query, it highlights how much benefit we can get from combining these two plans. So this query can run 3 times faster now by combining these two indices together. And it is guaranteed to be faster because first, with bitmap, we avoid a full columnar index scan, and also we can avoid a vector operation. And the benefit can even be more pronounced if we have multiple bitmaps, so it can be much faster than just 3 times. So Iris SQL provides a highly flexible architecture combining row-based, bitmap, and cost-based columnar execution. And also all these indices are useful, but they serve different workload patterns, giving you the best performance with minimal tuning. For the next steps in our big optimizer project, we plan to extend our cost model to recognize other vector operations like the vector joiner, and also we want to continue improve our cost model to choose the most efficient plan automatically. Thank you all.